And I would label all, each of like true west and east, I would do it on all of them. Just so I don't look at a line and get a little confused. And then Jameson, I would also draw the whole axis for magnetic, because sometimes what happens is your line might cross over the axes. If the declination is great, it might actually cross over axis, so I would always draw it. And if you were doing this on paper, you would be using a protractor, right?
Mm-hmm.
Use a square too, right?
Oh, yeah,
Use
use a
triangles.
square. That's a good idea. To get the right. Are you taping right now? Yeah. Okay, Jameson, I'm gonna have you stop for a minute. So everybody, what is his true axes? What color is it in? Black, right? And then which is the magnetic? It's the red, right? And the red, does that make sense? Like, look at the problem. The problem says the declination is 3 degrees 30 minutes to the east. Is that drawing correct? Should the magnetic axis be east of the true axis? Yes, that's correct. And then the magnetic bearing of a certain line was northeast 6335. Did he draw it right? He drew it 6335 to the east off the magnetic north. Is that correct? Yes. Okay, Jameson. Francisco.
Do you have any other colors?
Oh, look in the drawer. That should be green.
Want blue?
I already have blue.
Let's look in the drawer.
Oh, I was like,
Did I see some? I can't always bank on the ones in the drawer working well.
I was gonna ask, like,
Yeah.
so the,
Oh, yeah, Francisco.
the,
Sorry.
the True North, is that what, like, Magellan and all them, like, or like somebody just like drew, this is True North and that's it?
Somebody decided it.
Is it-
Again, you know, maybe I should know the science behind it, but I don't.
Oh,
So I can't
was
really
just
answer that question,
I do.
but we're all referencing, oh,
You know,
Patrick?
you know how like if you spin a basketball,
Yeah,
Is-
where it spins, oh, like the 23 and a half, yeah, I know, just,
there's a point where it
Yeah.
like everything is spinning around that point, right?
I feel you.
That's true north.
Okay.
What's arbitrary is whether you can decide that's north or south, but you know,
Okay.
there's those 2 points that
The
the
north
spin
and
goes
south,
through.
and then, yeah,
Okay. Okay, Jameson, just show us what you did there. So the question was, what is the true bearing of that line? So what's the true bearing of that line?
Yeah, look. 6, 7, 8, 5 minutes.
East. Okay. And how did you figure that out?
Since these are both going east, I added those together.
Right. Because that line, everybody look up here, that blue line is the line in question. We knew that the magnetic bearing of that line was north 6335 east. And now that line is still there in space, but now we want to measure the magnetic one from the true. So the angle, look up there again, the angle between the true north and that line is the addition of these two. So the true bearing of that line is north 67 0.05. Could you, Jameson, could you say equals true bearing? Okay, any questions? No? Okay, so everybody's comfortable with that, huh? Okay, so what's the next part of the question now? Now we want to know what is the magnetic bearing of that line in a different time period if its declination is now 4 degrees west. So Jameson, I'll have you sit down now.
Yeah.
And who wants to go up there now? Mason, you want to go up? Ruby, you want to go up? No? Ty? Okay. Alan, come on. Come on down! Woo!
Hey, nice try.
I don't know if you guys remember The Price is Right. Is
Yeah,
that still around?
yeah.
Yeah.
Oh, yeah.
It's the only show you have if you have antenna TV. You know, it's like, you know, captive audience.
I have a question. Can we continue the problem on the same axis we have?
Yes.
Would you be okay? We can. Wait, let's find a different
Purple up
marker.
there.
Purple?
I'll try to use the same.
Let's try to use the same axis. So right now we know, the black represents the true axis, right? The blue represents the line that never changes. And the red represents the magnetic when? In 1885, right? So now you're going to use the purple, and what's the purple going to represent?
2012.
What in 2012?
Magnetic.
The magnetic in 2012. So I'm going to have you draw it right on that. Okay? So this is the reason that it's good to draw this picture big, because we're putting so many lines in it, we want to be able to read it. So let's label that, right. And we might even want to do this, like for the red, we might want to say magnetic 1885. And for yours, you might, 2012. And then draw the same axis, draw the whole one, so draw the whole axis. Anybody colorblind in here? Yeah, Patrick,
A little bit.
my younger son's colorblind, or part of it, I don't know. And you know who gave it to him? It's me.
Oh yeah.
It's carried on an X chromosome.
Sorry.
I thought it was my husband's fault.
You're on camera, Joanne.
Oh.
We're live.
That was a student.
We're all students. Joanne's a lifelong learner.
Okay, so draw, and actually, I mean, how does this seem to you guys? And I'm thinking that, for me, I think I probably want to put, let's see, the 4 degrees was here, right? I probably would like to put, so let's go back to Jameson's, where's the red? So this right here is 330, I probably would put 330 here, right? And 330 here. And 330 here. Okay, and then for the 4, I would put the 4 here, just because for me, I'd like to read everything. This is 4 degrees, and this is 4 degrees. You can see how if you were doing it big with a protractor, it would be a lot neater than this, right? Okay. So Alan, tell us.
Should I do like this line too? Like,
Yeah, I think so. So the line that we're talking about is the blue line, right?
yeah, this blue line is our magnetic bearing,
The line represents the line in space. It was the line from me as a tree to Tristan as a tree. It's a line in space.
Like that?
The blue is a line in space, and all the other lines are the axes.
Okay. And then, to get our true, bearing.
What's the question? The question is, what is the magnetic bearing in 2012 when the declination is 4 degrees to the west?
Oh, to get the magnetic bearing. Yeah, to get the magnetic bearing, we would have to add 4 degrees to 63 degrees and 35 minutes because we wanna. This is our reference.
Okay.
North magnetic is our reference point.
What is the full angle from the north magnetic at 2012 to that blue line?
The
Could you draw it with draw with purple or something? Right, and what is that angle?
67 degrees
Okay,
and 35 minutes.
okay. Okay, plus. Oh, I see, you just added it.
Oh, yeah. Do you want me to?
Did you add it together?
Yeah, I think so. 63.
6335 plus 330 plus 4. Is that correct? Okay. So now, the question is, I want to know what the magnetic bearing is, right?
Isn't that?
So that's correct, that answer is correct, but when you represent a magnetic bearing, it's not just an angle, right?
Oh.
Right? So could you write on the board, magnetic bearing in 2012
Yeah.
is equal to?
North 67.
Right?
This.
Right. Good. Okay, so let's start with the beginning of the problem. So here's my true, and remember, the textbook calls it astronomic. The black represents my true axis. The red represents my magnetic axis in 1885. And the problem said the magnetic bearing, we drew the declination first. The reference is from the true, the declination is 3 degrees 30 minutes to the north magnetic in 1885. Then the magnetic bearing was northeast 6335, so the line in question is 6335 from the magnetic north in that period of time. So its true bearing is the line, the reference from the line to the true, so it's 6335 plus 330. And we got the true bearing is 6705. Does the true bearing ever change? No, true bearing never changes. So this black axis here never changes. So we have the true bearing now. Now the question says, what is the magnetic bearing in 2012 when the declination is 4? So out to the west. So Alan drew a new axis, the purple axis, which is magnetic north, and it's 4 degrees west of the true. The line is still in the same spot. So if I want to figure out what the magnetic bearing is of that line, I now need to get it from the magnetic north. So it's 4 plus 330 plus 6335.
Then the math is wrong. It's not 67. It should be like 71.
It's 7105.
Okay, so 63, 35 plus 330 plus 4. So that's 5, 0, count 7, 8, 9, 10, 11. 7105, sorry. So if I were to, if I was to take a device and I wanted to figure this out, I would have a piece of paper and I would have my line on it. And then I would have 3 such axes. And I would just keep rotating the axis to see what the angle is. Okay, you're gonna get a lot of practice on this in the homework problems. Okay? Let's take a break. Okay, so